friends, welcome to Meki Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support for creating these kinds of video and sharing it in a public domain. And next, I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore. And I would like to thank my almighty, my friends, my followers, and my dear students and my subscribers. Today's topic of interest is cams. We know that cams are the mechanical members which having a higher open pair. It is not a closed pair, it is a open pair element where the cams are mostly rotating kind of nature, and the follower which is attached in the cam having a reciprocating type of motion. In some of the application there is a linear cam as well as the rotary follower also. So first of all, we have to know the cam terminologies. The cam terminologies starts with base circle. The base circle is the base diameter of the cam, and next the followed by the prime circle. Prime circle is the circle followed by the uh, follower. It is a circle followed by the follower at the trace point. And next one is the pitch circle. Pitch circle is the maximum circle of the cam. And the next, cam profile, pitch curve, tangent to the pitch point, and the pitch point, pressure angle, normal to the cam, direction of motion. Trace point is a very important point for the cam. And the follower. Once in the cam will have a rotary motion, and the follower will have a reciprocating motion. Cams are having an eccentric rotation. Here this point is called as lobe. This is called as a top lobe point. In this point, when the follower reaches this point, it is having a maximum displacement, and where this angle is called as a dwell angle. So this angle is called as a dwell angle, where the follower will remains same. The follower position remains the same, which we are going to discuss the further. First of all, as I said, cam is a mechanical member and it is having a open higher pair. Follower and the cam are having a direct contact. And once again, I would like to remember this. The higher pairs are having either a point contact or line contact in nature. And here the cams and followers are having a direct contact. Cam motion is reciprocating or a rotary, and most of the time 95% of the cam and follower application is the cam is rotating and the follower is reciprocating. And the cam here, the cam is a driver member. In everywhere wherever the cams are used, all the cams are driver members and the followers are the driven member. The follower can rotate, can reciprocate, or sometimes it can be oscillating also. Here the frame is one thing which will support the cam and guide the follower. That is called as a frame. The applications of the cam and followers are automatic machines, IC engines, machine tool applications, printing control machines, and textile machineries, etc. Wherever we need an automation, there the cams are very useful for making an automation. And also nowadays the most of the vehicles are running with an IC engine are definitely having cam. The cams are the what to say cams are the very important important components of the IC engines, where in the cam all the valves are operating, all the spark plugs are operating, spark plug, diesel pump, all are operating. Okay, That is why it is an important element in the IC engine. And next we are going to discuss types of follower. We have a nearly an 8 type of a follower, and first one is the knife edge follower. The knife edge follower is having a very sharp point on the follower point, where the point of contact is in a point contact. Here the point contact, it is not a line contact, it exactly a point contact for the knife edge follower. And also the greater disadvantage is the wear in the knife edge follower. We can't maintain the the knife at every time, since the point contact there is a huge wear, therefore knife edge will not be there, and most accuracy is in knife edge. Next, roller follower. Roller follower, mostly the slow speed and pure rolling is happen. High speed sliding occurs. For the low speed, the roller followers are used. And here, for the parabolic motion, it needs uniform acceleration. And the flat faced follower or mushroom follower, or it will produce if surface stress or minimum. The follower, the surface stresses are minimum, and also there is no jamming takes place. And the next one is the spherical faced follower, and next one is the oscillating or rotating follower, which will make the follower in rotating motion. Next one is a radial follower. The line of movement passes through the center of the cam, and to decrease the pressure angle in an ascent, the follower is offset. So this point is very important. The follower offsets are mostly happens in radial followers only. In order to decrease the pressure angle, the followers are getting offsetted. Next one, it is an offset follower. The line of movement is offset from the center of the cam, and here it will produce low wear. Next type of a cam. There is a two types of a cam. One is a radial cam and another one is a cylindrical cam. The radial cam, the follower direction is perpendicular to the cam axis, that is called as a radial cam, where the follower direction is parallel to the cam axis, it is called as a cylindrical cam. Next, this is the important thing. Cams specification. Cams are specified by means of base circle, where in previous we have discussed the nomenclature of the cam, and the cam base circle is very important. The size of the base circle denotes the or specifies the cam size. Base circle is the smallest circle tangent to the cam profile, and the prime circle is the smallest circle tangent to the pitch curve. So these two words you have to remember. These two things you have to remember: cam profile and pitch curve. Next one is the pitch point. The point on a pitch curve having a maximum pressure angle, which is called as a pitch point. On the top of the lobe, it is having a pitch point. Next, if there is the cam and follower, since it is a higher pair and it is in the open pair, the forces are required to make the cam and follower in a closed pair. Therefore, the forces exerted by the cam and the follower are vertical force. Vertical force is the F cos alpha, and horizontal force, horizontal component, is equal to F sin alpha. And tangent cam with reciprocating roller followers, the displacement, velocity and acceleration are discussed here, and as well as for the tangent cam circular with the flat follower is also discussed, where the displacement S is equal to R1 plus R2 1 minus cos theta into secant theta. Here R1 is the minimum radius of the cam, R2 is the radius of the roller follower, and theta is the angle turned by the cam, and omega is the angular velocity. We know that velocity is equal to omega into r or omega into s. Therefore, s, we know that the displacement is s. Therefore, velocity is equal to omega into s, that is equal to omega into r1 plus r2 sine theta into secant square theta. As well as the acceleration is omega square into r1 plus r2 into 2 cos square theta into secant cube theta. Next one is the tangential cam or circular cam with flat faced follower. The displacement is equal to capital R minus R1 into 1 minus cos theta, and velocity is equal to omega into capital R minus R1 into sine theta, and acceleration is omega square into capital R minus small r into cos theta. And here we have some of the points to remember, that the pressure angle, which is very important for the cam profile, the pressure angle is the angle between direction of the follower motion and a normal to the pitch curve, or we can say steepness of the cam profile, which is called as a pressure angle. How long it is steeped, that is called as pressure angle. Here, if the pressure angle is too large, the reciprocating follower will jam in the bearing. Therefore, here we have two types of a cam and follower application. That is, cam and followers are used in automobiles or spherical faced follower, and where for the aircraft it is a roller faced follower. Therefore, the roller faced follower will have a uniform acceleration parabolic motion. Therefore, in the spherical faced follower it is used for in automobile. Next, the cam and follower motions. We have different kinds of motions. One is a simple harmonic motion. It is for low and moderate speeds, where the cycloidal motion it is for high speed application, and cycloidal motion are having good dynamic performance. And as well as uniform velocity follower, the acceleration in the beginning and the retardation at the end of the stroke would require to be infinitely high. And next one is the simple harmonic. For the extra point update, the simple harmonic, the rotating with the uniform angular velocity. Therefore, here it is producing low jerk, and maximum acceleration a is equal to h by 2 pi omega divided by phi the whole square. It represents the cosine curve. And as per the velocity, the high speed application is for cycloidal, and the uniform velocity is for low, and low and moderate we can use simple harmonic followers. Next one is the cycloidal motion. Cycloidal motion, the radius of the rolling circle r is equal to s divided by 2 pi. Here s is the displacement, and the maximum acceleration of the follower a maximum is equal to 2h pi omega square divided by phi. Here phi is the pressure angle. Next one is the prime circle. Prime circle is the circle passing through the pitch point with its center at the center of the cam axis, and the pressure angle depends on lift of the follower, angle of ascent, offset between center line of the cam and follower, and next the sum of radial of base circle and follower. And here you have to notice that the maximum value of the pressure angle is 30 degree. And for the uniform speed, the maximum speed of the follower Vmax is equal to 2 omega by pi, whereas velocity of the cam is ds by dt. Here, instead of dt and ds, we can multiply with the angle ds by d theta into d theta by t. That is simply multiplying d theta in both numerator and denominator. And we get the acceleration of the cam is dv by dt, that is dv by d theta into d theta by dt. Next is the trace point. This trace point in the roller follower, trace point is at the center of the roller. Simply in the roller follower, the trace point is very simple. It is the center of the follower. For the knife edge follower, trace point is at knife edge. The trace point is the pitch circle and pitch circle. Trace point is the pitch circle and pitch curve meet at a point is called as trace point. It is also called as pitch curve. I hope that you have all enjoyed the video and you have get a definite technology transformation for in the topic of CAM. I hope that I have given enough detail about the CAM. So if you have any doubts, please let me know in the comment section and I will make a clarity. Thank you once again.